This is Laboratory 3 of Week 6, the black hole orbit. This study will take a set of positions of a specific star versus time as it orbits a massive unseen object. The positions of the star and the black hole will be related to a standard Cartesian coordinate. The goal of the study is to define a system, observe the position changes on the system, determine velocity and momentum changes, and relate these effects to a cause, which is a net force, using Newton's second law. It will be shown that using position data of a star, the mass of the star, and the position of a black hole, the mass of the black hole can be determined. The system will be defined as shown. Only the star will be considered to be a part of the system. Everything else is environment. There will be no contact forces. The only non-contact force will be gravitation. Star mass is given. Star positions are given. The black hole position is given. Star velocity will be obtained as follows. Star velocity 1 will equal position 2 divided, subtract position 1 divided by delta t. Star velocity 2 is obtained by position 3 minus position 2 divided by delta t. This process is continued throughout the data. Star momentum 1 is obtained by velocity 2 minus velocity 1 times the mass divided by delta t. The rate of change of the momentum will be designated dp dt and will be obtained by momentum 2 minus momentum 1 divided by delta t. dp dt can be considered as two components at each instant. dp dt net can be decomposed into dp dt parallel and dp dt perpendicular to dp dt parallel. From Newton's second law, we know the cause of dp dt is the net force. Therefore, dp dt is equal to the net force. We know from definition of the system that the net force is the universal gravitational force equation of Newton. Using that equation, then, the mass of the black hole can be solved as indicated in the third blue box. Using these calculations and the iterative process in the Python program, the black hole mass was determined to be 5.37 times 10 to the 31st kilograms. This is the graphical presentation from the Python program. Interestingly, the mass of the black hole was not constant through the Python iterations. This is a graph of the results of the mass of the black hole over time, and additionally the star velocity. The star velocity can be seen to increase as the star approaches the black hole. It is at this point that the black hole measurement shows variation. It is my opinion that this is a computational artifact due to the iterative process of the Python program and the selection of delta t. This concludes Lab 3, October 1st, 2013.